Alright, now we want to talk about a transpose matrix. We got matrix A as an example here, and we say a transpose of a matrix A following what is interchangeable rows into columns, and again it's interchangeable columns into rows. So a transpose of a matrix A denotes a T like this. And we say, I said, say, from what is interchangeable rows into columns. So that's one matrix A. We got 2 rows and 3 columns. So I'm going to interchange the rows into columns. You got this first row, this one, by column, by row. Matrix A. So let's very transpose say over a column this time around. So I'm row 1, meaning kule new matrix of column 1. Again, Satan is 2. Lena row is 2. Kule transpose it over a column is 2. So interchange the rows into columns. By so doing, now columns are interchanged again into rows. Because if you can notice here, lo 2 0 bega first column, nyalo kuqhuba by first row. 3 7 bega second column, so kuqhuba by second row. 1 2 bega third column, kuqhuba by a third row. So that's how you get a transpose of a matrix. You interchange your rows into columns, or we interchange columns into rows. The same thing, you'll get the same answer. Another example, this is now matrix B is equal to 4 2 0 3 1 0 0 0. Then we want to find the transpose of a matrix of the matrix B. I'm saying either you interchange my rows into columns, no interchange my columns into rows, it will give you the transpose. So either way, as is going to interchange my columns into rows. Now I'm going to interchange this column. So this was the first column, meaning it will go over a first row 4 0 1 0. This was the second column, meaning it will go even the second row 2 3 0 0. Done. Now we've transposed this matrix into this one. Okay, my point to take here is, if you can notice, the order of this matrix was 4 by 2, since we had 4 rows and 2 columns. So if it's fully transpose, meaning say over 2 by 4. You know, we interchange rows into columns. That's why the order it saloba 2 by 4. 1 row, 2 rows, then 1 2 3 4 columns. Yeah, that's where you can, one of the ways you can see that you have transposed the matrix correctly. Unless maybe that matrix is a square matrix, so the number of rows is equal to the number of columns. The order will remain the same. I'll make another example. Maybe actually let me make an example of a square matrix. Maybe we got 2 0 1 1. This is the 2 by 2 matrix. 2 by 2 square matrix. Then if we find the transpose of matrix C, again we say we interchange columns into rows, or we interchange rows into columns. Same thing, we get the same answer. We get the transpose of matrix C. Ngethini ke lana, lena first row itokuqhuba first column, lena second row itokuqhuba second column. So just like I said, lena is 2 by 2 matrix. But then now say by transpose, as you can see, could say the rows are now the columns, and the columns are now the rows. You say this is the first column, say first row. This is the second column. Nyalo say second row. Maybe another thing again that would be much simpler for everyone. Good see starting on maybe if I consider on matrix A again 210, so order matrix then I 3 by 1, 3 rows, 1 column. Okay, if we say we want to find the transpose of A, in your mind you have to know that the order of the transpose will now be 1 by 3, right? 1 by 3. So meaning now you know that when expecting a matrix that is like this, that will have one row and 3 columns. So we're saying to matrix A, the rows they change into columns, or the columns they change into rows. So this is the first column, 210, 210. This column, the first column will become the first row. So now it's 210. Done. Now we're done. Another example. Let's say matrix D is equal to 4, 7, 10, 3, 4, 2, 2, 1, 0. Please add 3, 2, 1. The transpose of D, once again, either we interchange rows into columns or interchange columns into rows. So if I interchange columns into rows, meaning I will do like this, columns into rows. This is the first column, meaning it will become the first row now. Second column, now it becomes the second row. Third column becomes the third row. Fourth column becomes the fourth row. So now we've transposed matrix D. The order of matrix D was 3 by 4 because we had 3 rows, 1, 2, 3, 3 rows, and then we had 4 columns. Automatically we expect the transpose of matrix D to be 4 by 3, because we have now interchanged the rows into columns. So as we can see, we have 1, 2, 3, 4 rows and 1, 2, 3, 3 columns. But then there are some matrices, if we try to transpose them, you will notice that they become the same. They don't change. For instance, this is a 1 by 1 matrix. Let me use 7. This is a 1 by 1 matrix, 1 row, 1 column. So if we interchange them, we get the same thing. We interchange the rows. This was the first row. Now we have made it the first column, but it's the same thing. The order of this matrix was 1 by 1. So even if we interchange the columns into rows and the rows into columns, we still get 1 by 1. So this matrix doesn't change. How about this identity matrix 1, 0, 0, 1? So the transpose of A, the first row now becomes the first column. The second row now becomes the second column. Now can you notice here the order of this one was a 2 by 2, even the order of this one was a 2 by 2. But you can even notice that now in this matrix, beside the order remaining the same, but even the matrix remains the same. 1 0 0 1 1 0 0 1. So yeah, those are one of the special cases. Even a zero matrix, if you have maybe 0 0 0 0, the transpose of this matrix will also become 0 0 0 0, so it doesn't change, you know. All right, I think we are done.